Yes. Okay, so unless you're a pack of wolves, it takes a lot of energy to survive. And if you look on the internet, you will find a lot of stuff about solar energy for cooking and about generating electricity, but not very much for all the things in the middle. And I believe that's a lot of low-hanging fruit that we're missing. A little more quantitatively, some research has been done, at least in a village, which said that over half the energy went to cooking, but almost 20% apiece went to space heating and water heating. Space heating seasonal, but sometimes a heck of a lot of wood was consumed with space heating. So I'm basically a lazy person, and I think, that's a lot of work, that maybe that's not necessary. And I'm kind of a cheap person too, so I think that's a lot of money that's really not necessary. And we all know that burning wood can be dangerous for many reasons. And again, going back to being lazy, it takes a lot of work to build and maintain a fire. If all you're doing is heating water, there's got to be a better way. So what can the sun do for us? This is a two-part talk. The first part is about a general purpose solar heater dryer, which can be built by putting down, about 5 centimeters of insulation. And then something dark, I use black plastic just because it's easy to work with. And then the things that you want to heat, this could be, say, wash water. Or to get more energy, use more buckets. To get higher temperatures, use fewer buckets. And then cover the whole thing with a clear layer or clear or translucent plastic. The whitish translucent that's common works pretty well. It works just about as well as clear. So that's what the whole thing looks like. Let's see if this video will play. Hey! So the purpose of this video is to show that it's not too difficult wrestling with this plastic, even when the wind is blowing from any direction. Sometimes the wind makes it easier, sometimes the wind makes it harder, but it's not too difficult to do.
That's what wives are for.
I'm going to have to ask you to hold your comments until the very end of the presentation.
Make a joke about the peanut gallery at this point. I'll mention I'm not going to give too many numbers in this presentation, but if you do like numbers, I have a detailed report available with lots of numbers. I have 4 copies on paper there if you want paper, or I can obviously email it to you. So if you're heating water, you can use 1 or 2 buckets and get up to 50 to 60 degrees. A larger number of buckets, if you were working with, I suppose, 12 buckets, you would use 2 of these collectors, or I guess 1 twice as long, it's up to you. Or you can use jerry cans. The overall philosophy of this is that I want to give the user lots of options, and the user will decide for themselves what they want to do on a given day. More water, less water, heating, drying, some combination of those things, and have a device that can do a lot of different things. Wrong button. Here are some numbers. You can get up to 60 degrees with either full or 3/4 full buckets. Obviously, if you want your water sooner, you should use less. And of course, if you don't want to carry 20 liters of water, then you just use a not quite full bucket. It works pretty well on partly cloudy days as well as sunny days. Mostly cloudy days, of course, the performance suffers some, but it works surprisingly well on partly cloudy days. You can dry corn at the same time as you're heating water. The buckets of water, by the way, form a pretty nice structure for the device, so it's kind of nice to use the buckets whether you're going to use the water or not. The buckets form a nice space to hold up the top and so that you can work around. But here's some corn. Here's a drying rate. You're getting quite a bit of drying in 2 or 3 days. You can dry firewood. I don't think, so the thing there, maybe the best way to get less smoky stoves is to just dry the wood better. I'll spend a little bit of time on this graph since there's a lot of detail here that's not obvious. So this is for a collection of wood of all about the same size. before putting it in the solar dryer, the unsplit wood barely dried at all, and then after putting it in the dryer, it dried about 5 times faster. Split wood dries fairly fast on its own, so if you have split wood, then maybe you don't need this device. Split wood, of course, inside the dryer dried the fastest of all, and then split wood outside the dryer dried fairly fast as well. Typically, I think of about 20% as the maximum moisture content at which it's reasonable to burn wood. If it's wetter than 20%, it gets difficult to burn wood and much harder as you get up to the raw wood moisture contents of around 40%. The statement has been made that for wet wood, it is impossible to burn it cleanly in any stove. I don't know that that's literally true, but it's pretty generally true. On the other hand, if you have unsplit wood and you have the luxury of waiting 8 or 10 days to dry it, you can simply put it inside the solar dryer and not bother to split it. So again, saving work for people. It depends on the situation, but you have options. That's saying the same thing. Everything I know about Pootsie flies was taught to me by Krista, so she's now going to give us a brief introduction to Pootsie flies.
These are flies that occur in the tropical areas, and they lay eggs in wet fabric. And so I started wondering why people that don't have electricity bother with a charcoal-filled iron to iron their underwear and their clothes in the village. Not to look good, it's just to kill the eggs of the Pootsie flies. Because I tell you, a friend of mine didn't do it, and she had her bra washed, and so she had about 16 Pootsie flies just around her breast. And these are flies that lay their eggs, they develop into worms, and the worms grow under your skin, and they can be up to 2 meters long. Then you just have to slowly curl them up, and they're not nice, absolutely not nice.
So, with that was said a lot better than I could, so with that, let's see. So the Pootsie fly eggs can be killed at modestly high temperatures, let's say 55 for 30 minutes, probably somewhat lower than that, but I think that's a good upper bound. So what we can do here is put clothing, this is 3 pillowcases on top of each other, or a towel folded into thirds. That's probably about as thick a stack as I would want to go, but the clothing has to be flat on itself. You can't have it loosely jumbled around. But then temperature sensors underneath the clothing, and they get us up to well over 55 degrees, even on a cloudy day. So, I assume bed bugs are similar, but again, lots of options, and I thought the Pootsie fly one was a good one, again, saving people work and money.
And saving charcoal in many places, because that's the fuel that we use.
Mm-hmm. Let's see, pasteurization, many people at this conference know this already, but it is not necessary to boil drinking water to make it safe. You only need to pasteurize it, which is about 65 degrees or 60 for 30 minutes or so. This device can be used to pasteurize water in vessels up to about 2 liters. Beyond that, maybe you'd get pasteurization, but 2 liters is pretty easy to pasteurize, or other sizes. And then, of course, glass versus plastic. Plastic will shrink a little bit with the heat over time, but glass holds up well. It's best if the bottles are painted dark, but not absolutely required. But the point is, you can pasteurize water. I'm skipping a few slides here to save time and expecting that people will read this presentation later. One doesn't need to do fuel cooking or